Alright, this will be video 2 of structured text. In the first video, we showed how to do the first of the 5 constructs of structured text, which is the if, then, and else function. So to recap, there are 5 constructs. The first of the constructs is the if, then, and else function. The second would be the case, so in case of, and then the next would be for, do, while do, and then repeat until. So first off, in the first video, you see we wrote the logic for the if, then, and else function. If you would like, you could watch that video and kind of catch up on where we were. So I've already written the simulation logic and the main routine. I've already tied the main routine to the structured text routine via the JSR. So we've already jumped to the correct subroutine. Everything's working. To recap the process that we will be using, we are using the RSLogix 5000. And we are using the RSLogix 5000 emulation. So there is no physical hardware involved. You can do all this from your standard laptop if you have the RSLogix 5000, or if you have the whatever version of RSLogix 5000 you're using, you have that emulation software, which is I will add is a very helpful tool. For learning and progressive learning, or testing, even testing just code or whatever. So without further ado, we'll go ahead and start with the case construct of the structured text. Again, we have our structured text program. We named it structured text examples. We just added our structured text down here. I currently have that file open, so if you see, and I am offline, so if you see, that's what I opened. So what I'm going to do here is I'm going to just delete what we have as far as the if, then, and else function. This will be doing a case function. Okay, so this would be a little bit quicker than the if, then, and else function because it's basically you open it up with a case. So you open with a case instruction, and you'll close with an end case. So just keep that in mind. So first off, as you know, for our first video, we had 2 different dent files. We had state, and that's a dent. We had current state, which is a dent. So what we're going to be doing, instead of using the bits for that, for the controlling the state, we're going to be using the actual we're going to be comparing the 2 dents to each other to actually transition the state. So what we want to say is case state excuse me. So case state, and then we want to say case state of, and then we'll put 0, and then current state, and we'll put equals 0. So what we'll do here, so we're saying in case state, the state is in the state of 0, then the current state should be in a state of 0. So real quick, we'll copy and paste that, and we'll just change everything. So paste, oh, sorry. And if you recall, we had 6 states, so we'll go in and we'll say case of state 1, 2, 3, 4, and I have to add one more, and we'll pop that in there. So case of 6, and then we'll come down and on the back side of that we'll say what state it's currently in. So again, this is going to be fairly quick. It's not necessarily, as drawn out as the if and then function. So at the very end, you want to put case, and then end, and that would be that. That would be the very end of it. So we'll assemble that. It's probably going to tell me I have an issue. Right, so what we have to determine is what our issue is. So what we probably have done is we should have reversed this. In any end, you should put the end of what you're doing. So in that same focus, let's assemble again. Again, there's an AFI detected. We're not worried about that. That's something we're doing in our simulation logic. So just keep in mind, I did that kind of on purpose so that you could see that whatever you started with, like I said, we're starting with a case. So this is the case construct. Then we end. So you have to end first underscore case. So just kind of similar to what we did with the end if, and that was that's basically the same thing. So whatever you started with, you want to make sure you start the end and then whatever you started with, right? So you want to open the statement with a function, and then you want to close the statement with that same function. Like for instance, I couldn't come in here and put end if, like we did in the last one. It would think that it's okay, right? But obviously when you went to do it, it would come down here. Or if you went to assemble, you would come down here and it would give you an error. Again, the logic, the software will not let you use the software improperly. However, it will allow you to program it wrong. So with that said, what I mean by programming it wrong is like the logic can be incorrect. It doesn't monitor that you're using, because logic is basically whatever function you're doing or whatever function, that you're thinking how the machine should work is a logic function. However, the process of using the software, it will only allow you to use the software correctly. So again, this is a case, so we will assemble again. We have no errors at this point. So we want to again come down here and say we want to put in a comment in this one. So again, / we'll start our comments, and then we'll say in case of state or then transition to that state into current state, and then /. So that would be an example of us actually writing out what we did. So if somebody came behind us, they would understand exactly what we were intending to do with this logic that we put in for the structured text. So what we'll do is we'll download this now, and I like to just go to whoactive to begin. Again, we can download, Yes, we do want to go in run mode. And again, I've written simulation logic to function with this, and then the old simulation logic I had, I just kind of basically inhibited, and I didn't inhibit the actual routine. Because what I did is I added a jump feature and jumped around the old logic we had for our if, then, and else construct that we were testing out. So that is a good feature you can have if you do not want to use a section of logic, or if you want to scan around it and it not even be a working piece, right? So none of this would work. Even though I'm using the same bit to transition, even it should be working here, but these bits are not coming on because again I'm jumping around them. So again, not to get off topic, I just want to show you that I did write simulation logic. It's basically using the same timer. It's using the same bit as far as moving it. We're using a one shot, and we're coming down here and adding transitioning state to state to state, and then using that state. As soon as that state hits greater than 6, we'll move a 0 into it. So it's basically just a simulation logic, right? Really quick, cut and dry. And then down here I put AFI in front of this so you can see the current state is changing. Now the correct way to do this is to come up here to the view and then hit watch. So you can see that the current state is, or the state is changing, and the current state is changing with it. So as the state changes, the current state will change. So then if you wanted to, we could slow that down using this timer again. So let's just say 5 seconds, and come down here, hit watch again, and every 5 seconds it will change. And that's basically because, again, we're moving a value into state, the dent of state, and then it's according to what we've programmed here with the case scenario. If the state equals 0, then the current state will equal 0. If the state equals 1, the current state will equal 1. And just keep on going down. 2 will equal current state of 2 all the way down to 6. So that's basically how a case scenario does. It's saying if in the case of this state, or whatever, in the case of whatever this bit is, then if whatever it's doing, like say, whatever this represents, this could represent any number you wanted to. You could say in the case of state 20, and put a 20 right here, go to current state of 1. So we could do it in multiples of 10, and say in state 10 we would have 0, state 20 we would have 1, state 2 or state 20 we would have actually you kind of want to keep it level or even. So 0 would be 0, 10 would be 1, 2 or 20 would be 2, 30 would be, so we could do it like that if we wanted to. I'm keeping it a 1-to-1 ratio just to keep it real simple, understand what's going on. Again, that wouldn't be nothing to program. You come in here and say, let's change this to multiple of 10. So add 10 to it. Then right here we could say 60, and then this will reset. No worries, it will reset as soon as it's so. It'll get right in just a second as soon as it actually goes through the process. But we still need to come down here and change the logic. So we'll go to the Start Pending Edits, which is, again, looks like the little notepad. we'll come down here and state 0 is 0, 10 is 1, 20 is 2, 30 is 3, 40 is 4, 50 is 5, and 60 is 6. So in case of state 0, throw in a current state of 0. In case of state 10, throw a current state of 1. In case of state 20, throw a current state of 20. So we'll now assemble this, finalize all edits, and then make sure our logic is now lined up. It is. So with that said, we'll watch the logic and make sure it's doing as it's supposed to. So the current state is now 20. The state is now 30, 40, and then the current state is coincides with whatever we're putting in. So again, you can put whatever your number you want into this value, right? And say if it equals this, then do this. I mean, we could put whatever we wanted into that value and just make sure it coincides with over here on the left hand side. So the left hand side of everything, make sure that that value is, coincides with whatever state you're in. So again, in state, and we'll watch this go around. So in state 50, it's 5, 60, which is coming up 6, and then back to state 0. Of course, that's 0. 10 is 1, so that's happening. And again, you see how this works. It's a lot actually cleaner, simpler scenario, and the case of scenario is a lot better. It's a lot cleaner. It's a lot easier to read. So again, we'll speed this up, and we'll just say half a second. So now it's a half a second. So you can see it just skipping through the states really, really quick, and you can see it moving, doing the functions that we told it to do. Again, you can get it as fast as you want to. That's kind of why I've written the simulation logic. And just keep in mind, every time you write simulation logic, you write it for whatever you're trying to test. So the point of this video is not to show out how to do simulation logic. It is basically to show out how to write a case scenario. So the case construct, which in case of this, do this, then end the case. We want to show the case construct of the 5 constructs of structured text. So again, this is video 2 of the 5 parts of the video series that we're going to be doing. And again, I hope this was helpful. Hope you learned how to do a case scenario, how to use the case construct of a structured text program. And if you like the video, please subscribe. Again, we will be adding a lot more videos, a lot more just kind of things that help tie everything together, help just gain a higher understanding of the way programming is done. And just keep in mind that the programming is changing daily. It's changing all the time. Rockwell is getting more efficient. They're changing their software. So every little bit we can learn, via these videos and stuff like that. We just keep everything. We get a higher understanding. So when things do change, it's easy to transition from one to another. This is by no means saying this is the end all. This is just giving you an understanding of how a case scenario works in structured text. So again, we will be having all the 5 constructs of structured text, and I hope you enjoyed the video. And like I said, please subscribe. We'll be having a lot more videos, a lot more educational stuff to help out, and And please comment back. If you'd like to see something, let me know what you'd like to see. I don't mind, taking the time and kind of branching out and seeing what is helpful to you to guide you to the next step. Or maybe, we all have our blocking points. So we all have times that we really need help, and this is what this is here for. Nothing more. So, okay. Again, subscribe if you like, and we appreciate your time.